Hello viewers, welcome again to the MOOC course on IoT, that is Internet of Things, Design, Concepts and Use Cases. In this video, we will learn about the pin diagram of Arduino. Now, if we see the pin diagram, you can just see that one is your microcontroller, that is your Atmega 328, and also we have USB B port to computer that is showing in the diagram, and we have another port that is to input the voltage from 7 to 12 voltage. The other pins are we have shown, that is your 14 digital pins, and in the right side 6 analog pins in the left hand side. Besides this, we have the 3.3 volt output pin, 5 volt output pin, and as well as the ground pin in the left hand side. In the right hand side, in the pin 13, you are seeing that pin 13, and in the pin 13 we have one LED, inbuilt LED, that is if pin 13 has the high voltage, then LED will be on, otherwise it will be off. In the lower side of the right hand side of the board, we have the two pins, that is your receiver and the transmitter. And besides this, we have the interrupt that we have already discussed in the previous session, that two pins are for the interrupts, as well as some specific purposes. We have some pins that is for serial clock and master in slave out, master out slave in, and the slave select. So, we will see one by one. First of all, in the boundary box, we have shown the 14 input output digital pins, right, and these pins are used for either input or output by connecting them with the different external devices or components. Out of these 14 pins, 6 pins, these are capable for producing the PWM signal. Pins 0 and 1, out of those 14 pins actually, pins 0 and 1 are used for the serial communication, and they are used for the as I have told, to receive and transmit the serial data, right. Pins 2 and 3 are used for the external interrupt, that is interrupt 1 and interrupt 2, that has been shown in the diagram. An external event can be triggered using these pins by detecting low value, change in value, or falling or rising edge on the signal. As mentioned earlier in the previous session also, I have discussed that 6 of the 14 digital pins, that is 3, 5, 6, 9 and 10 and 11, these can provide the 8-bit PWM output, that is your pulse width modulation output, and pins 10, 11 and 12 and 13, those used for the serial parallel interface. Pin 13, as I have told, this has the LED, built-in LED. When the pin is of high voltage, then LED will be on. If it is of low voltage, then the LED will be off. Now, about the 6 analog inputs, there are 6 analog input pins which has the 10 bits of resolution, that is 1024, that is 2 to the power 10 different values. The analog pins on the Arduino are labeled as A0 to A5. By default, all the analog pins can measure from ground to, that is 0 voltage to 5 volt. Additionally, some analog pins have specialized functionality. For example, some analog pins are used for I2C, then UART, all this specific SPI of all these applications. Now, the USB cable, that is USB B port we are seeing. So, this is actually we are using for connecting, which will connecting the other sources, that is this USB cable which is used to program the microcontroller, that can be used as a source of power. That means, when you are connecting with the computer, this Arduino board will get the power, right. And there is another power jack with which we can input the 7 volt to 12 volt, that is also possible. Otherwise, V in is also there, so that we can input the some other voltage. Another part is your crystal oscillator, as we have shown in the boundary box, that this is the 16 megahertz crystal oscillator, and this helps the microcontroller to calculate the time and synchronize all the internal operations. This is the voltage regulator that converts the input to 5 volt, as Arduino board works in 5 volt, as I have told in the previous session. So, if you are supplying more volts into the Arduino boards, the voltage regulator converts it into the 5 volt. Subsequently, this signal powers up the Arduino board. So, these are the main features as I have already discussed. The operating voltage is 5 volt, we can give the input voltage from 7 volt to 12 volt, digital input output pins are 14, analog input pins are 6, and DC current for each input output pin is 40 milliampere, as well as DC current for 3.3 volt pin is 50 milliampere, and flash memory already I have told 32 kilobyte, and static RAM capacity is your 2 kilobyte. So, these are all the details of the pins. In the previous video also we have discussed about the different pins. And now the major benefits of using Arduino. First benefit is it is very cheap, inexpensive, and these are relatively cheap and low weight compared to the other microcontroller platforms. Cross platform is another advantage. Most microcontroller system are limited to Windows and only, but Arduino Uno or Arduino software runs on Windows, Macintosh, and as well as the Linux operating system. It is very simple and clear programming environment. Anyone can learn. It is very simple, easy to learn, easy to use for beginners, and it is very flexible, right. Next is your open source and extensible software and open source and extensible hardware. The Arduino software is published in an open source tool, so anybody can use it, anybody can modify it, those open source software, and can be used for the other purposes. As well as hardware, the Arduino is based on Atmels as I have told at MEG 8 or at Mega R68 microcontroller. The plans for the modules are published under a Creative Commons license. So, these are the main advantages of the Arduino. In this video, we have learnt in details the pin diagram of Arduino as well as the major features of Arduino or the advantages of Arduino. Thank you so much for viewing this video.